Okay, we are in the dimensions chapter. So this is a basic chapter, and even though it is given, very few questions are asked from this chapter for your board exam. But even then, we have to learn and understand the chapter here. Already we have learned how to write the dimensions. That is useful for you, because when you are coming through the various chapters throughout this year, through our learning this physics in the first and second year, and further in higher studies also, there certainly we find some importance with these dimensions. So just practice and learn how to write the dimensions. And whenever you come across a new physical quantity, there first try to keep in the mind the expression or a formula for that physical quantity, and by using that expression or the formula, we can write the dimensions. Once you learn the dimensions, once you learn this the formula or the expression for a physical quantity, and there itself write the dimensions, practice the writing the dimensions, and remember the units, the SI unit and the CGS unit. And if an SI unit and CGS unit both are there, then remember this conversion also. Okay, so like that, that's an instruction for you. And already I told you, whenever you are going through the video, and whenever I say pause the video and take the screenshot, just pause the video and take the screenshot, and you just go with the video and just focus on the video itself. Just listen whatever I am saying. And after completion of the video, go to your screenshots, open them, and prepare running notes for that. And for regarding your classworks or your notes, you will get a material, and there you can learn. Once you understand these concepts or the numericals, there you can understand the question and answers given over there, and the worked out examples, and you can do easily the numericals given there, the tasks given for you in the form of the exercises. So keep in the mind that maintaining a running notes for each and every session, video session you have. Okay, right. Now in this chapter we are at the uses. In the last class we were talking about the dimensions are used to convert one unit from one system unit from one system to another. There we have taken an example there. Conversion of the force units. Already you know there in your from your earlier classes, right from your 8th class onwards, you might have come across the units of force are the Newton and dyne. And this is the SI unit, and this is your CGS unit of force. And in your mind already you might have by hearted or kept in your mind that 1 Newton is, this is always to be written in a small letter. You know, writing the full form or it should be as a start with a small letter, and when writing the unit it should be as a capital letter. So 1 Newton is 10 to the power of 5 dyne. And here you know it and you remember it, but once if it is asked, just find it out by using the dimensions. You have to go for how to make this conversion by using the dimensions. Not only this, sometimes you may come across some different units for different physical quantities. There, without knowing the conversion between them, you can find out the conversion from one system of unit into the another system of another system. So how to make it? Already I told you. Once again, I am coming with this to make you to better understand. So here, so how to find this conversion using this dimension method? So first of all, write the dimensions for the force. Write the dimensions for the force. F is equal to ma. Now using this you can write the dimensions. Mass it is m1 and acceleration it is L1 t minus 2. Okay, now we have written the dimensions, and now let n1 be the value in one system and n2 be the value in another system. The meaning of this is, here already you know 1 Newton is 10 to the power of 5 times. So here, how to understand this n1 in one system is equal to n2 the other system is, it is n1 in one system. That means it is, let it be the unit in SI is equal to n2 the unit in CGS. n1 unit in one system, n2 the unit in another system. Okay, now n1. Now write the dimensions of this unit in SI. This what SI or CGS dimensions will be same. So write the dimensions of that physical quantity here. m1, L1, t minus 2, n2, m1, L1, t minus 2. To show the difference here, what I am using is, I am just keeping the different suffixes here. So this is x, 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 y, y and y. So x for SI and y for CGS. Now here I want to find what is the value of this n2 and what is the value of n1. I will focus on this n2 for finding out n2. So I will write like this: n2 is equal to, bring this side. If you bring this side, this n1 will be here, and this comes to the denominator. Like this. Now separate to write down the mass, length and time. That means various dimensions like this. n1 mx by my. So this is 4 to the power of 1, whole to the power of 1. Lx, Ly. So they are having the same power, that is dimension, that is 1. Tx, Ty to the power of minus 2. Now take this, the mass, mx, m in the mass in SI and the mass in CGS. What is the unit of mass in SI? It is 1 kg. It is kg. Just we'll take it as 1 kg here. In CGS it is gram. 1 gram. Now just to bring it into a single value here, I am writing this in the grams. It is 1000 gram by 1 gram. 1 kg is 1000 grams. So this goes away. So this remains as 1000, and I will be writing it as 10 to the power of 3. Okay, so mx by my you got it as 10 to the power of 3. Similarly, write for length dimensions, Lx by Ly. What is the SI unit of length? It is meter, so 1 meter. What is the SI CGS unit of length? It is centimeter, so it is 1 centimeter. For making the conversion here, 1 meter is 100 centimeter. So instead of 1 meter, I am writing 100 centimeter, and it is centimeter. So it is 100, and I am writing it as 10 square. And coming to time, Tx, Ty. The SI unit of time is 1 second, and CGS unit of time is 1 second. So it is 1. So now I got this as n1, mx by my, it is 10 to the power of 3 to the power of 1. Lx by Ly, I got it as 10 square. So 10 square to the power of 1. Tx, Ty, it's 1. And it is minus 2. So it is n1, 10 to the power of 3 to the power of 10 to the power of 3. It is 10 to the power of 2. Anything to the power of 1 is 1 itself. So it is n1 to 10 to the power of 5. So now we got here as n2 is equal to n1 into 10 to the power of 5. So from this, how to write an expression for our conversion? So now if this n1 is equal to 1, then n2 is equal to 10 to the power of 5, isn't it? Suppose if you consider it, suppose you want to write the expression, you want to say 1 unit is equal to how many units there? 1 unit on this system will be equal to how many times it will be there. So if this is equal to 1, and so it becomes n2 is equal to 10 to the power of 5. Okay, now we got it as n1 is equal to 1, n2 is equal to 10 to the power of 5. So now, coming here, n1 into unit in SI, n1 into unit in SI is equal to n2 in unit in CGS. n1 unit in SI is Newton. What is n1? We got it as 1, so 1. n2 it is 10 to the power of 5. Unit in CGS is time. So 1 Newton is equal to 10 to the power of 5 time. So like this you can complete the conversion. Easily you can, I think now you can understand easily how you can convert one system of unit into the other system. The same method you can follow for whatever the physical quantity it is. Okay. Now pause the video and take the screenshot, and we'll go with one more example, taking one more physical quantity. Then the question is convert CGS unit of work to its SI. To its SI unit. We know the work, the SI unit is joule and the CGS unit is erg. The same procedure, whatever we have followed earlier, the same, we can use it here. And we want to write this, the dimensions for this work or energy, both are same. So it is W is equal to, use the formula F dot S or F into S, F dot S. So F already we know, M1, L1, T minus 2 for this F, and for this S it is L1, so it is M1, and for this M1 L square and T power minus 2, L1 becomes L square, L2, so it is M1 L2 T power minus 2. Alright, now that's what we are going to do. N1 into one system of unit, or I can take it as SI is equal to N2 into CGS. Okay. So N1 at the dimensions there, M1, L2, T minus 2, and it is N2, M1, L2, T minus 2. Same physical quantity, same dimensions. Now just to show the difference here, I am changing the suffix X, 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 Y, Y, and Y. Now I want to find the value of N1 and N2. So N2 is equal to N1 Y. So I can write like this, L1 or 2 minus 2. Now taking this like this is SI and this CGS, this is in kg, This is in gram. 1 kg is 1000 gram. This is gram, so it is 10 to the power of 3. So Ly, it is 1 meter and it is centimeter. So it is 100 centimeter, 1 centimeter, so it is 10 square, and Tx, Ty, it is 1 second, so 1. So now I can write like this, M1, we got this ratio as 10 to the power of 3 to the power of 1, and this ratio as 10 square, 10 to the power of 2, 1 to the power of 2, and 1 by 1 is 1. So N2 is equal to N1, 10 to the power of 3, 10 to the power of 2 into 2, it is 4. 1, no need to mention it. So it is N2 is equal to N1 into 10 to the power of 10 to the power of 3, 10 to the power of 4, it is 10 to the power of 3 plus 4, it is 10 to the power of 7. So now we got it as N2 is equal to N1 into 10 to the power of 7. Now we'll take this 1 as 1, and 1 is equal to 1, then N2, if N1 is equal to 1, N2 is equal to 10 to the power of 7. So from this, N1 into SI is equal to N2 into CGS. So N1, it is 1, the value we got it as 1, and SI is, it is joule. N2 is 10 to the power of 7 arc. So 1 joule is equal to 10 to the power of 7 arc. Okay, I think you might have understood very well. And go for a practice. Take a screenshot of this and go for a practice. We'll come with one more thing. Okay, here one more numerical is given for you. So this is an application for one of the uses of your dimensions. That is to find the correct relation between the physical quantities. By using this to find the correct relation between physical quantities, we can derive an expression. So basing on that, this is one more example here, and this is for your practice. A problem, important problem, right? So now already dimension for a physical quantity is given, so no need to worry. You can easily go with this. Here, the critical velocity V for a liquid depends upon coefficient of viscosity. You will come across this going in the along with the chapters, and there you can understand. But here the dimensions are already given, so you can easily go with this. Density of the liquid and radius of the pipe. Using dimensions, derive an expression for the critical velocity. So we have to derive the relation for expression for critical velocity. So from this it is given that critical velocity V, critical velocity, just you can keep in mind, critical velocity is nothing but it's also a velocity. So this depends upon viscosity. It is eta. The symbol is eta. It's a Greek letter. Eta. And depends upon the density rho, it's rho, and radius r. So this depend, how it is depending we don't know. So just I will make it as x. And how this velocity depending upon rho we don't know. So I will make it as y. And how this is depending upon radius we don't know. So similarly here Z. So now I will be writing the expression as V is equal to some constant k eta to the power of x, rho to the power of y, r to the power of z. Now here using the dimensions we have to find what is the value of x, what is the value of y, what is the value of z. If we are able to find this, your problem is solved. No need to worry about this k value. This k value we will be getting from the experimental values. We'll be extracting it from the experimental values, and then you can go through that. Earlier also we did for this. T is equal to k root of L by G, and k is 2 pi. This from the experimental value, T is equal to 2 pi root of L by G, isn't it? The same thing, whatever we did there, just we are going to do the same thing here. So anyways, here we wrote the expression like this. Now I have to find x, y, and z. How can I find this? These are the physical quantities, and left side one physical quantity there is there, and right side some other physical quantities are there. So now, just by the principle of homogeneity, here the dimensions of this side, left hand side, will be equal to dimensions of this right hand side. That's the same thing. From the principle of homogeneity, we know that, we understood that, and we are going to apply this here. So now, from this, what are the dimensions of velocity? L1, t minus 1. And right mass, there are no dimensions, so I am giving it as 0. Mass, there are no dimensions, so 0, L1, t minus 1. K, constant, no dimensions, and eta, so it is viscosity, and the dimensions are given as m1, L minus 1, t minus 1, raised to x. Rho, it is density. For the dimensions of density, it is mass by volume, so m1, L cube, m1, L to the power of minus 3. So m1, L minus 3. And it is, what assumption we made here? To the power of y. And the radius is nothing but the length, so dimensions are L. And here we assumed it as Z, so it is Z. Okay, now here it is m0, L1, t minus 1, k. Look at this, m1, m1. Okay, now it is. So okay, here comparing the dimensions of mass here, so it is I can write like this. Before that, k, m, x, and y, it is x plus y, and for L it is minus x plus y, and here another one is there, that is z. So it is x minus x minus 3y and plus z. And time, here only one is there, that is minus x. So now comparing the dimensions for a physical quantity on left side and right side, according to the principle of homogeneity, they should be same. So for mass it is to the power of 0, so dimensions of 0 here and dimension x plus y, so they should be same. X plus y is equal to 0, so from this we are going to get x is equal to minus y. And length, here it is 1, minus x minus 3y plus z is this side. So according to the principle of homogeneity, and this should be same. So it is minus x minus 3y plus z is equal to 1. And next it is, and for the time it is minus 1 and minus x. So minus 1 is equal to minus x. So x is equal to 1. So 1 already we got it here. So if x is equal to 1, x is equal to minus y, or y is equal to minus x is equal to minus 1. So the third one also we have extracted here. And coming to the third expression here, minus x minus 3y plus z is equal to 1. I'm just taking this. Minus x. So x is equal to 1. It is minus 1. Minus 3, y is equal to minus 1. Plus z is equal to 1. So minus 1, minus 3 into minus 1, it is plus 4, plus 3 plus z is equal to 1. Minus 3 plus 1, it is 2 plus z is equal to 1. And z is equal to 1 minus 2, so it is minus 1. So we got as x is equal to 1, y is equal to minus 1, and z is equal to minus 1. Coming to the expression, what we have assumed here, this one. So v is equal to a eta to the power of x. Power of x means it is 1. And rho to the power of y, it is minus 1. And r to the power of z, it is minus 1. So I can write like this, eta, power of 1, no need to represent. If this is minus 1, I can take it to the denominator, it is rho and it is r. So thereby we got a beautiful expression here. This k value can be, it is not asked for us to, because k value is not given here, so we can leave it like this. So now here we got the expression for a critical velocity. So this is the way how we find what is called as the relationship between the physical quantities using the dimensional method. Okay, so now pause the video and take the screenshot and go for a practice thoroughly. Okay, see you in the next session.